All right, greetings again, everyone. Welcome to the third part of the video now for section 8.2. And here we're going to start looking at the graphs of functions given in polar coordinates, which sounds exciting, right? Yeah. Okay, so over here on the left, we're given two polar functions. So one of them is r equals 2. The other one is r equals theta over pi. And the first thing I want you to notice is inputs and outputs here. And it's going to be easiest to see, I think, in the second equation. Okay, the r equals theta over pi. Now, what is our input variable there? Well, it looks like it's the theta, right? Because that's the one with some numbers on the right-hand side. So the input variable is theta. Okay, and then the output variable in this case would be the other one, right? So that would be the r. So it looks like in general, and this is true in polar functions, our input variable is theta and our output variable is r. Okay, so with that in mind, let's look at now graphing these functions. So the first one we have is r equals 2. And notice in this case, it doesn't actually mention the variable theta at all, right? And so it seems not to matter what the value of theta is, the radius value is always 2. So it looks like this is some sort of a polar version of a constant function. So how could that work? Well, if we think about plotting some points, right? So let's say we input theta equals 0. Well, again, there's no thetas in the equation here, so that gives us an output value of r equals 2. So when theta is 0, r is 2. Should also remind ourselves that along the outside here, this is pi over 6, this is pi over 4, this is pi over 3, and this up here would be pi over 2. Well, if you input pi over 6 into that r equals 2, again, there's no thetas in the equation, so we just get r equals 2 again. And the same thing for pi over 4, and then pi over 3, and pi over 2. If we go run to pi, or 3 pi over 2, regardless of the angle we input into the function, we get r equals 2 as the output every single time, right? And so if I plot all those points and then connect them, you probably already see the shape we're going to get, which is a circle, right? So something like that. So a constant function in polar, we have r equals 2, gives us something like a circle. Now, as I mentioned, we can also plot this on a Cartesian coordinate system. So we just need to, in this case, go out 2 units in each direction. So we get, say, something like this. And the scale is a little different over here on this Cartesian coordinate system. All right, so that is that first one. Now, next we're going to look at the r equals theta over pi. And we're going to go kind of old-fashioned with graphing here, where we're going to make a table where we'll input values for theta and then see what we get as our output for r. Now, I've already done this on a separate screen, so let me show that. Okay, so here's my input-output table. Notice, again, as we mentioned, the theta values here. These are the inputs, the r values are the outputs. And you can see the coordinate pairs we have. So we have the point 0, 0, pi over 6, 1, 6, pi over 4, 1 over 4, pi over 3, 1/3, pi over 2, 1/2, and so on and so forth. And if you're wondering where I got those from, remember that the formula was r equals theta over pi. So if we input a value for theta, say pi over 6, this would be pi over 6 divided by pi, dividing with fractions here, so we can make the pi a pi over 1. So this would become pi over 6 times, instead of pi over 1, we could get 1 over pi. Here the pi's will cancel, and then we end up with just 1/6, right? Which is what we see up here. So this is where these numbers come from, and you could check through that we get the same thing for that I have here with pi over 4, pi over 3, and pi over 2. Okay, so we'll go back to our graph now, and we're going to plot these points and see what we get. Let me do that. And I'm going to go through and start plotting. So our first point was at a theta value of 0. The radius was 0. So if we don't rotate it all and not go at anything, that gives us a point right there in the center. Sorry. There we go, like that. Our second point is pi over 6, comma 1/6. So if you recall, pi over 6 was here. So we rotate around pi over 6, go about 1/6 out from the center, which is kind of hard to see there. The next one we would have pi over 4, which if we input that, we get 1/4. So that means we go pi over 4 and about 1/4 of the way out. And then pi over 3, excuse me, be our next one. And so we'd go around to pi over 3 and go about 1/3 of the way out. And then at pi over 2, we had 1/2. So we'd go up about halfway on there. And I know this is getting really kind of hard to see what's going on, but also if we input pi, well, pi over pi will give us a 1, so we'd give a length of 1 there. At 3 pi over 2, we would actually get 1.5, or 3 over 2. At 2 pi, we would get 2. And now if I start to connect the dots here, you'll see that what we start to get is not that. We kind of get a spiral type shape. And so if we were to continue, we can do something like this, okay, which is kind of cool. So yeah, that's what the graph of that function would look like. Now, one thing I want us to keep in mind or think about here is if you think about in Math 141, Pre-Calculus 1, would a spiral like this, a spiral shape, especially if I put it over here in this Cartesian coordinate plane, would that pass the test to be a function, considered a function in Pre-Calc 1? And hopefully you're saying no, it wouldn't, right? Because it doesn't pass the vertical line test. We draw a vertical line, say right there, we see it intersects the graph in more than one point. And in fact, I can draw one over here that hits it in like 3 or 4 points if I drew that vertically, which I didn't. Oh my goodness, hold on. I can do this. There we go, more like that. And so, but if we look at the function we had, the r equals theta over pi, that's a perfectly fine function, right? If it was in, say, terms of y over x, saying y equals x over pi, there's no problems with that function. So the cool thing about, or one of the cool things about polar functions is that they allow us to describe curves or graphs that would normally not be considered functions in our Math 141 or Pre-Calc 1 way of looking at things, which is kind of neat. Now, the other thing you notice about this is it's kind of a pain to have to draw these graphs by hand. So thus, in the next video, we'll look at then graphing these things using our calculators. Okay. All right, that's it for now. Thank you for watching.